All right, hello pre-cal. We are skipping lesson 5.2, so we're just going right to 5.3. Sketching polynomials with multiplicity. Multiplicity is super cool. We'll talk a little bit more about multiplicity in a second. But today, our goal is to be able to sketch a graph of a polynomial in factored form, so that's a whole bunch of bubbles, using the leading coefficient and the multiplicity. So we have two things we want to do. The leading coefficient is the, if you were to multiply everything together, it is the leading term. I should have said leading term, not leading coefficient. The leading term has the highest power of x. And we want to look at that leading term. We want to know if it's positive or negative, and we want to know if it's even or odd. So for instance, if we had something that was like positive x squared, well, you know that that's a parabola. And because it's positive, we know that its arms up. And because it's got an even power, both of the arrows point up. All right, so if we have an even power, and this is true for x to the 4th, x to the 6th, x to the 8th, anything, looks kind of the same. It just has some extra little bumps in the middle. What happens when it's a negative x squared? Yeah, sure, the arms point down. So anytime, again, you have an even power for the highest power, then those arrows are both going to point in the same direction. So even arms means that they match. They're both pointing up or they're both pointing down. And because it's negative, they're both pointing down. Now, if we have an odd power, so say it's x cubed, then what happens is my polynomial starts low on the left and ends high on the right. And so this is basically increasing, got a positive uphill sort of slope the whole way. Now there might be some bumps along the middle, but overall it starts low on the left and ends high on the right. So I call these odd arms because they're sort of wonky. One is high and one is low. They don't match. It's odd. And so if we had negative x cubed, again, we have odd arms. So one is high and one is low. But in this case, they'd be going downhill because of the negative in front. So we're going to start high on the left and then low on the right. Every polynomial you can imagine is dictated by these four end behaviors. All right. And if you know those, you can do a lot. So we're going to talk about how to get all of that. But first, something very cool. Look very carefully at these graphs and their corresponding equations. What connections do you see between the equations and the behavior at the zeros of the graphs? So zeros are where it crosses the x-axis, or where it touches the x-axis. So look at all of these zeros and pause the video and really see if you can match what's happening in the graph, recognize a pattern between what's happening in the equation. All right. So pause your video and come back in just a second. Okay. I have some special colors, blue, green, and purple I'm going to be using here. So what is multiplicity? Well, multiplicity is whenever you have a power on one of these factors. So this power of 2 here, that means that we have multiplicity 2. multiplicity. Don't try to look it up because it's not there. Multiplicity 2. Here we would have multiplicity 3. And so you can see some of these here. We have a 0 that's got a multiplicity of 3, multiplicity 2. Right here, it's a multiplicity 1. And so you can see all of these little factors have, this would be multiplicity 1, multiplicity 2, multiplicity 2. So those powers cause very interesting things to happen. So let's look really carefully here. Here I have, let's start with this right here. I have a 0 at x equals 0. And at x equals 0, it has a multiplicity of 1. And you can see that the graph at 0, it's almost linear. It's like a straight line. It passes straight through the 0. So if you have a multiplicity of 1, it causes you to pass straight through that 0. So anytime you see that, and so let's see if we see that somewhere else. Where are we passing straight through? Right here at 2. So that corresponds here to the 0, x equals 2. So at x equals 2, it's a pass straight through, almost like a line, because it's multiplicity 1. Where else? Right here. At 1, we have a pass straight through, and you can see it has multiplicity 1. And here at 2, there's the factor. It also has a multiplicity of 1. At x equals 2, here it's x equals 1, it passes straight through. Really interesting. The next thing that happens is you can see this little behavior where it's kind of like it's bouncing off the axis. That happens at x equals 2, which is right here. So that's what's happening when we have a power of 2. So a multiplicity of 2 causes a bounce. And so graphically speaking here, at -3, you can see how it's bouncing from below, kind of interesting, but you see that factor has that power of 2, so it causes a bounce. Here at -3, right here, it has a multiplicity of 2. Also at 4, it has a multiplicity of 2. Very interesting. And here at -3, there, x equals -3, it has that multiplicity of 2. So you can see how the factor and the power corresponds to what it does at the graph, which I think is totally cool. What's the last thing that we have here? Here at -3, we have multiplicity 3. So here's the 0, x equals -3, and you can see that it has a multiplicity 3. So what happens with a multiplicity 3? I like to say that it has a slide. So you know those like wedgie water slides where you cross your legs or you get a giant wedgie? That's what this looks like, doesn't it? You go really steep, and then you got a little bump in it, and then it goes down again. So this is what I call a water slide, a wedgie water slide. And that's what happens at the 0. It sort of comes in and gets almost flat. It does get actually flat and then goes back down again. That's a cubic. So it has a cubic shape at that 0. You can see it right here as well. This is going the other direction, going uphill. But again, it has that sort of slide to the right. And that's happening right here with that x cubed power. So really quite interesting. And so this is multiplicity. It's those powers on those factors. If you have multiplicity 1, it's a passes straight through. Multiplicity 2 is a bounce, and multiplicity 3 is a slide. So you can slide down to the right, or you can slide up to the right. Okay, so let's see how to do this by hand. Of course, you can use your calculator. But honestly, this is just so cool. You want to do it by hand. All right, we have a couple requirements. This is the best Delta math program I think I've ever seen. So example 1, sketch the function with the proper x and y intercepts. And so you also need to know the leading term as well. And so we will figure all of these things out. So very first thing I want to do here is you can see that this polynomial is already been factored. And so I can right away figure out my x-intercepts just by setting each bubble equal to 0. So do I set -2 equal to 0? No, because -2 does not equal 0. It doesn't have an x, we can't solve for it. Here we get x equals -3. You'll also notice that the power there is 1, so it has a multiplicity of 1. All right, so there's one x-intercept. Here we get x equals +3. It has a power of 1, And so it also has a multiplicity of 1. And the last one here, we get x equals -4, and it also has a multiplicity of 1. So graphically, what happens at each of these zeros? Because they're all multiplicity 1, they are going to pass straight through. All right, very important that we think ahead. All right, let's find the y-intercept. Y-intercepts occur when we plug in a 0 for x. So I'm going to find f of 0. Turns out it's usually pretty easy. -2, we've got 0 plus 3, we've got 0 minus 3, and we've got 0 plus 4. Well, that's going to be -2 times 3, that's -3 times 4, and I'm just going to use my calculator. Maybe if I was a little more coherent. 72, all right? So pretty big. We get 72. So the y-intercept is at 0, 72, and we can graph that. So that's another thing you need to know. So 72 is the y-intercept. And then the last thing that we need to know is the leading term. And so the leading term comes from when we multiply everything together. Well, guess what? You don't have to do that. All we need to do is look very carefully. First, I see I have a -2 times, and all I care about really are the x's. X to the first power. Here we have x to the first power, and then x to the first power. And so that's going to give me -2 x to the third. So I see that I have an odd power, and it's negative, which means it's going to go downhill from left to right. So it starts high on the left, and we're going to end low on the right. So that's important to know as well. That tells me where to start and where to end. Once I know that, I'm going to go ahead and make a sketch. So here are my zeros on the x-axis. So 1, 2, 3, 4, -3, and 1, 2, +3. And I also have my y-intercept at 72. So again, don't do 72 tick marks, just label it. And you probably will need to do this by hand first, and then draw it on Delta Math. So on Delta Math, you just have to do a nice continuous click with your mouse. So a drag with your mouse. And it's pretty good, but you do need to hit these points pretty close. So because we have an odd leading term, I know that it's going to start high up here on the left. So I'm going to draw my arrow up high on the left, and it's going to end low on the right. And in between, I'm going to hit all of these zeros, starting with the one on the left. And I'm going to pass through that one first. So pass straight through, and then I have to turn around so I can pass through the other one. And that's going to make me hit my y-intercept, and then I'm going to pass straight through 3. And there you go. There's our super awesome polynomial. Let's try the next one. So my x-intercepts are already here. We get x equals 1. It has a multiplicity of 1, which means I'm just going to pass straight through. Here we have x equals -3, but it has a multiplicity of 2. What happens to that one? That's right, it's a bounce. It bounces off that 0 because it's been repeated. The y-intercept is when I plug in a 0 for the x. So that'd be 0 minus 1 to the first power, and then 0 plus 3 to the second power. So that's -1 times 9, which is -9. So my y-intercept is -9, and my leading term, I don't have anything in front, so I have x to the first times x being squared. So that's going to give me positive x cubed. What does that mean? Again, we have odd arms, and they're positive this time, so they're starting low and ending high, going uphill from left to right. So I have a 0 here at 1, and 1 to -3, and 0, -9 for my y-intercept. Now, these arms start low on the left, so I'm going to start down here, and I'm supposed to end up high over here. At -3, which is this 0 I'm going to hit first, I'm bouncing. So I'm bouncing from underneath. So I'm coming in on the left and bouncing. passing through 9, and then continuing up to the right. And there you go. Now, of course, you can check these using your calculators, so feel free to, when in doubt, graph it out. You can type in x minus 1, x plus 3, and double check your graphs before you do anything. And you could cheat and do it this way, sure. It makes no difference to me. But honestly, it's totally cool to be able to do this. I used to amaze my students when they'd want me, I'd have them make up an equation and I'd graph it, and then they'd check on their calculators and they're like, oh, that's so cool. Yeah, it's pretty cool. Of course, I'm a math teacher. What do I know? All right, x-intercepts here. I can't set that equal to 0. There's no x. So we get x equals 3 with a multiplicity of 2. What does that mean? Bounce. All right, bounce is off at 3. And here we have x equals -1. Again, it has a multiplicity of 2, which again means a bounce. Y-intercept, plug in zeros for x. We have -1/8, 0 minus 3 squared, 0 plus 1 squared. And let's see, so -1/8 times 9. So -9/8 for my y-intercept. So that's a little lower than -1. And then my leading term, again, don't leave off that negative. Is so important. -1/8 times, we have x being squared times another x being squared. So that's -1/8 x to the 4th power. So here we have an even arms. They both match. They're either both up or both down, and because it's negative, they're both going to be down. Even arms match. All right, so we have -1 and 1, 2, 3. And then my y-intercept is -9/8. So here's 1. I'm going to call this -9/8. -8/8 is -1. So this is a little lower than that. Now for my arms, I know that I'm starting down low and I should be ending low as well. I'm going to approach this first and I'm bouncing. So I'm going to bounce off that -1, pass through my y-intercept, and then bounce off the 3. Again, I missed a little bit, so, but there you go. It's kind of like a M shape. Last one, here we go. Isn't this fun? I just love this stuff. I think it's so cool. All right, my x-intercepts here, we get x equals 1. Ooh, multiplicity 3. What happens with that one? Yeah, a little slide through it, wedgie water slide. X equals -3. Here we have a multiplicity of 2 from that power of 2 there, and that's a bounce. Okay, y-intercept. Plug in zeros for x. We get -1/5, 0 minus 1 cubed, and 0 plus 3 squared. So -1/5. -1 times -1 times -1 is -1. 3 squared is 9, so we're getting a positive result, 9/5. So that's, well, 1 4/5. All right, not quite 2. Leading term, we have -1/5 times x being cubed times, here we have x being squared. And so that's going to be -1/5 x to the 5th for my leading term. So once again, we have odd arms, and they're negative, so they're going downhill from left to right. I have 1, 2, -3, and 1 for my zeros. 1 4/5 is 9/5, so it's almost 2. And I'm starting up high on the left and ending low on the right. So at -3, I have to bounce. Bounce, pass through my y-intercept there. And now, we have to slide through the 1. So that means I'm going to approach here to the left and slide along the x-axis and then continue down. It's a little tricky to learn how to draw, but you'll get it with a little bit of practice. So, ladies and gentlemen, multiplicity 1 is a pass, multiplicity 2 is a bounce, and multiplicity 3 gives us a little slide. Whee! All right, folks, have fun with that. I think it's so cool. Get that done. It's really neat.